What will happen when robots talk to each other? Everything is ready for it? A new stage of artificial general intelligence based on autonomous communication between robots in real time will arrive. Based on duality theory. Edited by Jesús Velásquez-Bermúdez. Artificial intelligence through human brain modeling. In 1943, Warren McCulloch and Walter Pitts created the concept of artificial neural networks. They published the article, A Logical Calculation of the Ideas Immanent in Nervous Activity. McCulloch and Pitts tried to explain how the brain could produce highly complex patterns, by using many basic cells that are connected. Neural networks were growing, and in practice they took the name of artificial intelligence. They were also called machine learning. Artificial brains are an invention of high, due to their expertise in complex modeling. Artificial brains are the next methodological step for artificial intelligence, that is still stuck in neural network-based modeling, based on data processing, ignoring precise mathematical models. High is not aware of mathematical models developed with this approach. Two different worlds. Without fear of being wrong, it can be said that as people and organizations travel the path from arithmetic to parallel thinking, an abyss is being generated, which is concretized in the speed with which a society produces knowledge and wealth. Human language. Language is the human ability to communicate through sign systems, such as speech, writing, and gestures, which allow thoughts, ideas, and feelings to be expressed. It is a complex system that includes grammatical rules, lexicon, and phonology, and varies between cultures and communities. Many of us have stopped to think about how our ancestors began to speak. After all, if there is something that differentiates us from other animals, it is language, and at some point, we had to invent it and start using it. It is impossible to give an exact date to the origin of language. Some of the most important data to consider are the following. 400,000 years ago, Homo erectus would have already developed the brain areas of Broca and Wernicke, related to the production and understanding of language, respectively. Although it may be that he used them for other functions. There are theories that place the origin of language with that of Homo sapiens, which seems to have begun its journey 50,000 years ago in Africa, after a severe glaciation. Other authors propose a possible proto-language, simpler, from about 100,000 years ago. Why was the creation of language so important for humanity? The creation of language was crucial for evolution and human development because it allowed complex communication, the transmission of knowledge, social organization, and the construction of culture. Thanks to language, human beings were able to coordinate actions, share experiences and knowledge, and develop a collective identity. Language, in its communicative function, is the basis of social interaction, allowing the expression of ideas, feelings, and the understanding of others. Because language is the instrument of human development. Autonomous real-time robots communication. The state-of-the-art of artificial intelligence is the Generative Pre-trained Transformer, GPT. It's a type of large language model, an LLM, and the framework for generative artificial intelligence. It is an artificial neural network used by machines in natural language processing, which is based on the Transformer deep learning architecture, pre-trained using large datasets of unlabeled text, and that can generate novel human-like content. A LLM is a machine learning model that can understand, generate, and translate human language. LLMs are trained on massive amounts of data, such as text from the internet. They can be used for a variety of natural language processing, NLP tasks. Most LLMs have these characteristics and are sometimes widely referred to as GPTs. Autonomous real-time robots communication. McCulloch and Pitts theory, which has existed for more than 80 years, has proven to be totally successful, and based on it the current state of artificial intelligence has been reached, which we could say are GPT methodologies. However, Velásquez-Bermúdez's work, spanning 35 years of research and technological development, has resulted in artificial brains, which are a new way of thinking about artificial intelligence. The structure of an artificial brain is made up of the artificial hypothalamus, hippocampus, and cortex, all of which perform functions like human equivalents. Artificial brains come from neuroscientific studies. The construction of the artificial cortex determines the connectivity of the artificial neurons, which are associated with the atoms of the system. In mathematical models, it is common to use a matrix that establishes the relationship between columns with variables and equations with rows. These matrices are scattered. This is the basis of cortical modeling. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. Emphasizing that Hai is not an expert in neuroscience, its interpretation of the functioning of the brain is presented. The cerebral cortex stores all the connectivity of the neural networks that make up the brain. The hypothalamus is the organ that ensures the proper functioning of the human being. The connectivity of neurons in the cortex determines how the hypothalamus should function. The hippocampus is responsible for managing memory, which interacts with the hypothalamus, to determine the actions that the human being will perform, that is, decisions. Artificial entrepreneurial brains are based on these hypotheses. Donald Oldingheb is best known for his theory of Hebbian learning, which he introduced in his classic work The Organization of Behavior in 1949. Hebb has been described as the father of neuropsychology and neural networks. The central concept of Hebb's theory is summed up in the phrase, cells that fire together, wire together. According to this idea, when an A neuron is repeatedly involved in the activation of a B neuron, the synapses between them are strengthened. This principle suggests that the concurrence of neural activity is the basis for learning and memory. Synaptic strengthening: when a presynaptic neuron and a postsynaptic neuron are activated simultaneously, the connections between them are strengthened. Activity-dependent plasticity: the efficiency of synaptic connections is not static but can be modified as a function of neuronal activity. This plasticity is essential for adaptive learning and memory. From the point of view of Hai, one part of the artificial hippocampus processes the information stored in the other part, to develop a learning process. Learning takes the form of the generation of new neural connections, which must be stored in the artificial cerebral cortex, to be used in the future by the artificial hypothalamus. This high vision of artificial intelligence, built from the workings of the human brain, is currently unique in the world. From the point of view of Hai, one part of the artificial hippocampus processes the information stored in the other part, to develop a learning process. Learning takes the form of the generation of new neural connections, which must be stored in the artificial cerebral cortex, to be used in the future by the artificial hypothalamus. This high vision of artificial intelligence, built from the workings of the human brain, is currently unique in the world. Autonomous real-time robots communication. The robot language implemented by hypothalamus I. One of the scientists who has most influenced Hai's work is Jeff Hawkins through his publications, such as Why Does the Neocortex Have Layers and Columns? A Theory of Learning the 3D Structure of the World, and his book 1,000 of Brains, in which Hawkins presents a vision of artificial neural networks based on neuroscientific studies. 1,000 Brains theory of intelligence implies multiple models of an object. Each model depends on a point of view. All models work cooperatively to identify the object, or situation. The identification starts from the sampling process, and progresses until it finds that all the models converge, that is, they agree, and at that moment the object, or the situation, has been identified, and the process is done through the flow of information in the neocortical regions. Another important contribution of Hawkins is related to the multiple brain models of the same object working cooperatively. For example, to recognize an object, 5 models of that object can intervene, each of them generated by one of the senses that the human being enjoys. Complete knowledge occurs when the knowledge generated by all models in all layers are integrated. Hawkins' ideas led to the creation of the multi-benders decomposition algorithm, MBD, whose coordination is like that carried out in many companies where central planning must comply with multiple planning dimensions, which must be attended simultaneously by multiple divisions, or departments. From a parallel computing standpoint, each subproblem can be associated with a core configuration, or CPU, that simultaneously generates asynchronous information to solve a common problem, such as the human brain. Under an asynchronous parallel scheme, all the models involved must be processed in parallel, and through the coordination model to share information, which in a next iteration will help other models to advance in solving the problem. This functioning is equivalent to how a human hypothalamus works, in which all vital systems work in parallel to achieve the common good. The best decision. Large-scale optimization and artificial brains. One of the fundamental ideas of the artificial brain is the atomization of the system, bottom-up approach, to integrate multiple mathematical models, using the framework of large-scale optimization methodologies, like multi-level Bender's theory, and Lagrangian relaxation. Atomizing a problem does not imply modifying it, simply dividing it until the elementary components are obtained. If in a real-life context the system is atomized, the number of problems to be solved would be innumerable. Each problem can be associated with an algorithm or a cognitive robot. So, you can say that an artificial hypothalamus has an infinite number of neurons, each of them represented by a mathematical problem, what He calls a mathematical artificial neuron. Joseph Louis Lagrange was an Italian physicist, mathematician and astronomer, who after training in his native Italy spent most of his life in Prussia and France. Lagrange duality provides a framework for addressing constrained optimization problems, by constructing its dual problem through the Lagrange function. In many cases, dual problems serve as valuable tools for analyzing the primal problem. Although in his time, solving a real problem with his theory was practically impossible, based on his knowledge many researchers have been expanding the applicability of his theories, until they reach artificial brains that are soluble thanks to Lagrange's theory of duality. In the same way that artificial intelligence based on artificial neural networks has been developed, thanks to computational power, today it is possible to solve atomized optimization problems using large supercomputers and Lagrange theory. This is the basis of a universal language for robots. The central part of an artificial hypothalamus is the formalization and the standardization of a math language between cognitive robots, to be used as the way to communicate multiples math algorithms. The core of this language is the duality theory, that support the mathematical programming algorithms, that may be developed using the concepts of large-scale optimization methodologies, to solve high-complex math models based on the partition and the decomposition of the real-life complex systems. An artificial hypothalamus corresponds to a superalgorithm that coordinate multiple cognitive robots that operating simultaneously, autonomously, in real time, acting as the human hypothalamus, to achieve a common goal. By joining all the concepts presented here, it is possible to define a language between robots, math problems, algorithms, or agents, based on an exchange protocol of information between the multiple types of problems, in which any pair of robots communicate by exchanging the information produced by each of them, which is synthesized in the value of the primal and the dual variables that they produce. If each robot is identified by the R index, in each conversation step K, the actions of each robot are inputs, dual and primal variables that our robot uses produced by other robots. All the data available until the begin of conversation step K is characterized as the historic knowledge database QK. Outputs, primal and dual variables that produce the robot R, it can be characterized as XKR, PKR. Transformation function FRQK, mathematical problem that the R robot solves to produce XKR, PKR, starting with QK. Mathematically this is XKR, PKR, equals FRQK. QK equals QK minus 1 union with XKR, PKR, Q0 equals. When our robot receives information QK it processes it generating information, XKR, PKR, and a conversation step K plus 1. The robots receive, or search, the inputs produced by other robots, and produce the outputs to be used for other robots. The information produced is added to the historical, and it is stored in the artificial hippocampus, an intelligent database on disk, or in RAM, which can be accessed in the next conversation of all robots. Then, based on large-scale optimization methodologies, communication between robots is synthesized in the transformation functions FRQK and in the storage of all the information produced, XKR, PKR, in an optimization knowledge database, QK, which can reside on RAM disk, offline, or on RAM memory, online. In a static problem, frontier conditions fixed, when the coordinator robot detects that has enough information to establish the optimal decision, it proceeds to close the conversation cycle, and terminates the optimization process. If the problem is dynamic, frontier conditions time-dependent, the robots will have a continuous conversation in order to keep the system as close as possible to the optimal decision path, which is not possible to obtain due to system uncertainty. This process, based on duality theory, is the support of artificial hypothalamus capable of processing the information required for Industry 4.0. Swarms of robots based on autonomous, real-time robots communication. If large-scale multi-level optimization methodologies, based partitioning and decomposition of systems, are applied to get the smallest atom of a dynamic stochastic, the number of algorithms they generate could become countless. If parallel processing technologies, such as microservices, are used, the solution of a mathematical problem would be carried out by a swarm of algorithms that work autonomously and permanently to achieve the goal proposed by the decision maker. This algorithm swarm approach is currently used in artificial intelligence to manage swarms of robots, but the rules that robots follow are simple, logical and intuitive, and have no solid mathematical basis. An artificial brain can be visualized as a swarm of algorithms, cognitive robots, which have a communication structure based on a multi-level sparse matrix, and whose communication protocol is governed by mathematical laws aimed at obtaining team results. The new way of mathematics is directly related to the parallel thinking, and today it can be said that like paper-based math, sequential mathematics for single-processor computers will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Thank you for your attention.